Hi, this is John Reed. I got the old school guest of the year, Vijay Vijayasankar, IBM. How's it going?
Very good. Great to be back. Been a while.
Feels like it's been a long time, man. But some of these online conferences we had in the past were some of the best chats. So hopefully we can do it justice today.
Sure hope so.
So for those of you catching this, we're going to be hitting on a topic that came up in the back channel with Vijay and I, and it has to do with hiring, specifically around the challenge of data science skills and sort of powering the so-called AI workforce from a human side. And the reason this really struck a chord with me is because I really preach this gospel that essentially the companies don't do enough, even within, say, the U.S. or any geography, but just take the U.S., to reach out to much more diverse and underserved workforces and train them up and all that stuff. Well, Vijay on this topic came at me from a totally different perspective because his view is with this particular set of skills, it's very, very hard to find enough qualified people. And so I want to learn more about that and how he's creatively approaching that. So let's just take a step back here and just tell me about like the kinds of skills that you really need that are hard to find and how that's going for you.
Yeah. So to frame that discussion right on where I come from, if I look at the last 3 years that I spent at IBM, right, I first supported three different industries like utilities, media and entertainment, telco. Then I ran the analytics AI consulting business for North America, supporting all the industries. Then I was the North America CTO for a while, and now I run one of our large financial services accounts. So I came at this from a few different perspectives, so hopefully can provide a balanced view of the problem. So first things first, there are a lot of jargon problems in this area to begin with, right? So people get very hung up on, is it AI, is it machine learning, oh, isn't it classic analytics, is regression really machine learning, and so on. While it is interesting to debate academically what the big differences are in terminology and so on, this is pretty much a relook at the past when we were all haggling about, is it BI, is it analytics, is it reporting, and so on. It is not the highest value problem to be tackled at the moment. The highest value problem to be tackled is who can solve the big ticket issues that my clients have, right? And for that, one thing I realized early was that it is not one data scientist who solves problems. It is a combination of skills which usually one person doesn't have. And I have gotten into trouble with friends in the past for writing a post that said there are no data scientists in the wild. My general point there is, for data science to be useful to a business, it needs to be a team sport. It needs some statistics type experience. It needs some computer science experience. It needs storytelling experience. It needs good visualization experience. It needs a lot of domain experience, which all combined in one person makes it a unicorn, and consequently makes it very hard. And a lot of people who recruit data scientists often don't think about this team nature of this work, and then get very frustrated later when it doesn't give them the type of benefit that they want, right? So that is how I would frame the problem upfront. This is why hiring this perfect data scientist is tough. I think if we rephrase the problem to, can we find the perfect data scientist team or data science team, I think we will have a lot more success in solving this skills problem, because they are not always going to be in the same person. Does that make sense, John?
Yeah, I think you hit on a couple really important things there. First, in terms of definitions, I don't want to spend a lot of time talking about the difference between AI and machine learning and automation on this particular discussion. But I think, to me, what resonates the most is I interviewed a company the other day that's using AI type stuff for recruiting. And what he ultimately said to me is, I don't know if this is AI or this might just be a really well-written program. All I know is that I'm getting results with it, and that's kind of what I'm looking at right now. Is right now the role of machines, as I see it, is to automate the mundane and automate the transactional and automate things that free people up for higher value work. And if you can also help them make decisions and start developing alerts infrastructures and help predict things, then that's even better. Is that an acceptable framework, do you think, for our discussion?
Yeah, absolutely. Right. I mean, we should think about not just in AI, but in general, computing in general, right? Is it solving an efficiency problem, or is it solving an effectiveness or efficacy problem? Right, they're two very different things. Automation, as a general theme, has always been great at solving the efficiency problem, doing more with less. The efficacy problem, the effectiveness of the solution, slightly different, right? Because these are dependent on us being able to ask questions that were not asked before, and software trying to figure out answers that it was not capable of finding them. So the AI kind of spreads between these two axes, right? If we think about efficiency and effectiveness as two axes of the problem space, AI kind of covers both. Most of the narrow solutions that we do are very high value on the efficiency space. Like in recruiting, if you have to go through 100,000 CVs that came in through your portal, AI is probably a great solution in getting it shortlisted. It also will come with a ton of problems like bias and other things that we consciously or unconsciously didn't take care of, right? So everything comes at a price, but at least it is better than spending 3 months trying to go through 100,000 CVs when you really need the guy or gal, the next day at work.
Yeah, and I totally agree on the other principle around the team concept here, and that this isn't really about some rock star coming in and sort of waving the magic data science wand. Recently, I went to an industrial analytics session put on by Baker Tilly, and they were describing a scenario where they had run a bunch of advanced analytics. This was for an airplane parts manufacturer that was having some issues they were trying to hone in on. And it wasn't until they sat down with the engineers and the specialists and the managers with the data that's when the light bulb started to go off, right? So they were able to crunch numbers and provide information that customer didn't have, but it was sitting down with the domain experts that have been in that field for 20 years and looking at that, and they were immediately able to say, oh, okay, I see why this is an issue, right? And they couldn't have done that just coming in with a wagon load of smart consultants.
Yeah, absolutely important, right? If we don't solve a problem in the context of that industry and that customer in particular, AI is of low value, right? I mean, there are two classic examples to make the case. One, most of us have heard about correlation doesn't indicate causation, right? I mean, that is very well understood. But if you're exploring a large data set, you will find a lot of correlations, and most of them might not indicate causation. But what is perhaps less understood is that correlation also doesn't convey importance. Just because you found something statistically valid and it might be sufficient for causation, it still doesn't mean it is important for that business. You wouldn't know as a math geek or as a computer science expert whether that is important for the business till you talk to somebody from the business, right? The domain expert. The second, classic case is false positives and false negatives, right? A good use case of AI is diagnostics, right? Why a machine went wrong, or in another context, say diagnosing a disease. You have to ask this question, right? If a false positive comes or a false negative comes, what is better? What should the system do? Should we tell somebody who has a disease that he doesn't have a disease, or somebody who does not have a disease that you have a disease, right? I mean, this is not very easy for a machine to make a determination. It needs a human doctor, or in the case of a machine, a production supervisor to take a call. So those are all, those are two simple, straightforward examples. But, within those ranges is a ton of things that a data scientist might not be aware. Now, often, people who have worked in that field for a long time, even if they are not business facing, do pick up these skills and eventually at some point might be great at bringing the domain knowledge. But still, right, somebody who is close to the business, whose life is affected by the decisions that the AI system makes, that person should have a say and should understand clearly, transparently what is happening behind the scenes.
Right. So as we hone in on the skill sets that are hardest to find, let's take this. I realize every customer is kind of different, but let's take the scenario of a project like the type that you've been involved with. What skills do you look for from this team for the customer to provide, and what skills do you look to provide from your side?
So some customers, especially the one that I support now, are very, very savvy on AI. Right? They have been doing machine learning for a long time, even before it became fashionable. Like fraud analytics and so on has been around for decades, right? So I can't really teach them anything that they don't know on that front, right? So the trouble there usually is they may not be aware of what is happening in other industries that they can learn from, because AI is solving magnificent problems in multiple industries. And if you don't know what is happening elsewhere, you probably will spend a lot of time relearning, reinventing the wheel, and so on, right? So I provide some value in cross-pollinating that information across clients, across industries, which hopefully is high value for the client. The second difficulty is there are also new research, that crops up in AI from time to time, which, unless you are in this business full time, is very, very difficult to keep on top of. Right? I cannot keep on top of everything that happens, but thankfully, my employer has a significant investment in research, so I get to talk to the researchers and get a nutshell of what they are working on, what breakthroughs are happening, and if something I can correlate to my clients' problems is there, then I can ask for a deep dive. Some of the times what I find is I need to go brush up on my math and stat skills before I can get a full appreciation. And this in turn affects my hiring decisions quite a lot too. There are a lot of algorithms that come prepackaged, or models for that matter. If you come from the statistics side of the world, they they abstract away the need for people to understand the mathematics behind how these things work. But it also comes with certain limitations that if you don't understand the first principles of how a solution was arrived at, you're very limited in terms of the value that you can add, because then you're essentially picking, it's like a multiple choice answer that, you're just picking one answer out of many, which in many cases would be still higher value than what a client has. But you're limited. You're not really going to stretch the value much bigger than that. So I do expect my data scientists to have a good mathematics understanding, statistics understanding, so they understand the first principles of how their solution works and can explain in simple terms what has happened. Like a good example that I ran into recently was creating odds for investment decisions. And while there are very sophisticated models, and the model will give some indication of the accuracy of its prediction, people start taking it very binary, right? So, for example, there are two options. Option A has 55% odds, and option B has 45% odds. That shouldn't equate to a human interpreting that, okay, let me double down on option A because it has higher odds. Because people don't generally understand probability and concepts like that very easily. So it is important for me when I hire people that their first principles grasp of their domain is high. I put a lot of value on that, and also there a level of pragmatism. It shouldn't a lot of things you cannot learn in college, but there are pragmatic limitations in how much you can work with. Like, for example, how much data do you really need? What kind of compute environment do you really need? Are you aware of where the best algorithms and the best data sets reside that can add value to what you're analyzing now? those are things, right? That curiosity element that makes people explore beyond what they learn in college is of significant value to me, right? So those are all things that I generally poke a lot when I interview and select folks to work in our team.
Right. So you've talked about the difficulty of hiring folks in the U.S. with some of these skills. What are the skills that are really proving most difficult from that standpoint?
So there are a few universities, like Carnegie Mellon and New York State and Northwestern and so on, where we go and recruit every year in some volume. So we get great students from there, and most of them have prior experience before they did their masters. But it is a small set of people compared to the demand in the market. It is only a very small set of people, and they are pure data scientists, right? I mean, they learn data science for a couple of years. They do, capstone projects and so on, and they're very well prepared. And they have a very short learning curve to be where they need to be. And then
So when you say they're pure data scientists, break that out a little bit. Do they have advanced mathematical degrees as well? When you say pure data scientists, how would you define that?
Many of them do, right? Either advanced mathematics degrees or engineering backgrounds, where you do need a significant mathematics as part of your curriculum to pass that course. So they may not.
They understand how algorithms are constructed, and they could probably construct their own.
Or I would like to think if they don't, then somehow I would have spotted it and not recruited them. Right. So, so that part is important, right? That the depth of that skill. Now, I'm not saying that every single person with the data science, title or a data scientist title needs to be that way, but you do need several of these people because there should be somebody, who has that first principles understanding in the team to explain. But it's probably less important when they talk to other data scientists, but it is very important when they explain it to a client, right? A non-data scientist person, how they arrived at that conclusion, what the system is actually doing, and what are the caveats that should go with it. So that is a basic requirement, that a significant part of that data scientist population in a team ideally should be first principles savvy. And this math background does help. Now, when I say math background helps, sometimes they do understand the maths really well, but they still have a problem interpreting that in simple language. So that is just about as bad as the prior case where they don't have the math knowledge. What I need is them understanding first principles and then being able to explain in simple language to their clients. So it's a complicated skill. It is something that perhaps universities could do better in educating them. There are other things that are considered optional in the university curriculum that I really strongly feel should be core curriculum. One is this ability to explain. The other is things like fairness, ethics, right, of AI. These folks will be working with high value data sets and solving big problems in their career. And a topic like ethics cannot be an optional subject. It cannot be an elective. It should be part of the core curriculum. They should not wait till they're halfway through their career to realize, oh, maybe I shouldn't have done that.
It's interesting because you're kind of describing kind of a rare combination of a strange blend of liberal arts sensibilities and hardcore math science sensibilities, because that the ethical and sociological implications and the privacy implications, that's not taught in the hardcore science curriculums nearly as often.
Yeah, as far as I know, there are no core curriculum components that teach these things. Right? There are electives in some colleges that teach this. And I strongly believe that it cannot be an elective. It needs to be part of the core curriculum. And absolutely, you're spot on. I truly feel that all engineers need a dose of liberal arts education while they are in college, or at least get their curiosity raised on there is this other discipline that they can tap into while they are still young and impressionable, so that they they continue to learn after they finish their formal education.
Yeah, it's interesting because what you kind of described is that if I could be a data science rock star with an advanced math degree, but if I lack a certain understanding of, for example, uh, data privacy issues across cultures or across organizations, or if I'm not able to communicate effectively and think critically, then I'm going to be a very limited use to you.
Correct.
Yeah.
And yeah, it absolutely important. And also, I think the other, gross injustice, from their younger days is how their expectations are set on what their day-to-day life will be. A significant portion of their life will be just wrangling data and getting it into a shape that they can do their advanced work on. And many of them walk into the job assuming that somebody else would have done that job for them.
Right.
And then they get very frustrated. This also, I think, could be addressed very early in their career. I try to talk to them, right in the interview process to set their expectations straight, and I continue to talk to them throughout their initial years in the team, because there are simple things that if you don't have your expectations set on this, you probably will get way too frustrated and quit. And your dreams will be crashed for no good reason. I mean, these are all interesting problems to solve, but it is a problem. And data, you will be very lucky to get what is called clean data. I haven't really seen clean data come at me in any project in my life.
Yeah, I keep seeing surveys that confirm what you're saying and report that data scientists should expect that data manipulation, cleansing, and quality is going to be a significant chunk of what they do, whether they would like that or whether they enjoy that work or not. And it's almost like if the CEO of an organization's also got to be the janitor, in a way you have to be the cleaner of your own data and not expect someone else to do that for you.
Yeah, and it is actually an excellent point that you make there, John. Actually, most CEOs, right? I mean, over the last several years, right? I have had several CEOs as my clients. There is a janitor nature to some of their decision making. Oftentimes the CEO will have to look at conflicting data and make a decision, right? Like their business unit presidents might make one forecast, their finance, CFO organization might make another forecast. Market analysts might give him a third view of the world. And he or she has to somehow come to a complex conclusion looking at data that might contradict themselves, right? It's that wrangling, although it's not Python work that he does. It's still you have to rationalize in your mind that not this data driven decision making has that one limitation, that at the very top it is very rare that everything is clean, and you often have to make a decision with incomplete data, despite all AI, ML, BI, ERP, and other assorted things we all do.
Yeah, I often think that modern success in our world now, in the so-called data economy, it's all about moving out of your comfort zone. Whatever you are most comfortable and think you're good at, you're going to have to learn something that you're not as comfortable or good with in order to be effective, right? So you're going to have to know how to talk to programmers. You're going to have to know how to be more technical. Technical people need to understand business process and design. And so, no matter where you sit, you've got to be willing to push a little bit if you want to be relevant.
Yeah, no, totally true, right? I mean, and some things, right, are just honest mistakes that you don't realize till sometime later in life. A good example is how you visualize what you found out from your analysis. I always say that the simplest visualizations are the best. If you give a chart with like 17 lines going this way and that way, it's pretty tough to understand for anybody other than the person who created that chart, right? Or putting a pie chart can give very different ideas to people. I often tell people don't put pie charts on your presentations for that reason.
Right.
So there are those kinds of things that if you're taught early in your career, you can probably live with less grief, over the time. But we all make mistakes that in hindsight look like totally avoidable if only we thought through.
Right. So what do you do in this situation when when you have all these projects pending, and you don't have enough people, really, like you said, there's only so many people you can hire from certain schools. Does that mean are you hiring outside the U.S. more? Are you trying to get creative? Like how do you handle these shortfalls at the moment?
Yeah, so one, college is limited given there are only so many students that come out of college every year, and we get our fair share, and other companies compete for the same talent. So that's the first avenue. The second avenue would have been hiring outside the US and bringing folks on a temporary visa or doing that work remotely. But USCIS has tougher visa requirements now, so that is not always easy. Plus, there are company policies that our clients that often do not allow their data to be shipped offshore for analysis. Where we can solve those problems, that outside the US is a fair solution. But then there are still other issues like expertise in, say, ERP. You want to add machine learning to your ERP solutions. It is not enough that the machine learning aspect. You also need to know the process, right? How does code to cache work in an ERP? Is not something that you can teach a data scientist in 2 days. It's tough, right? So for you to, and it is also tough to teach machine learning to an ERP specialist in a couple of days or weeks. So it is important that we cross-pollinate knowledge between these two teams, that where we see repeated patterns, like, for example, machine learning in ERP is a thing. It's high value, and there are repeated problems to be solved there. So it makes a lot of sense to give introductory training to the ERP specialists on machine learning, right? We are not the only company doing that. I'm sure there are other people doing that. And in return, the machine learning folks also get some business process knowledge, especially where it is repeated patterns. Then it's very important for them to know that. So we cross-pollinate that. Then testing is another very interesting aspect, right? Because these are not deterministic systems, right? Like, for example, you can ask a question on what is my invoice total today, and if you ask that same question tomorrow, an SAP system will give us the same answer, hopefully the same answer. If the answer is different, there should be a very good reason why that happened. Whereas the questions that we typically ask a machine learning system, it is not always going to be the same answer. There will be minor differences between how the system answers today and tomorrow in many cases. Not in all cases, but in many cases. That means testing now needs a paradigm shift, and they need to understand how AI works, how training a model works, how bias needs to be minimized, and so on. So testing is another competency that will get disruptive. Project management, yet another critical aspect, where it is not very easy to do blueprinting type strict approaches on how an AI project should work. So that discipline also needs some rethinking on how to manage a machine learning project or an AI project. So we do a bunch of cross training, and so there are many such levers that, in a small way, you can tweak several levers and solve this problem. But I honestly believe, and one good thing that has happened is there are data science boot camps, and these online courses have become mainstream. So the distribution channels have become much easier these days, right? So if you want to learn the basics of machine learning, and you have a month to devote, nights and weekends or whatever, most people can get up to speed very quickly, right? So that is one huge benefit that the times that we live in, we have, that we never used to have in the past. So all these things, right? I mean, a combination of these things. No one thing that solves our problems, but a combination of these things helps solve the problem.
Yeah, and it sounds to me like we have a situation where you can't sugarcoat the fact that if you want to be a hardcore data scientist by your standards, it's really important to have that mathematical discipline and background. And so for those of you listening that aspire to that part of the role, you gotta pursue it. And whether it's formal schooling, I hear what you're saying about online, and I think that can work, but I think you have to have a lot of self-discipline to teach yourself advanced math concepts online. That's not a simple thing. That's not like learning content marketing or something, which I've done online. It's a challenge, but I think you can do it. It's just, you have to have some determination.
This is true, right? This is very true. And I think our school systems, right? I mean, the earlier we catch and solve these problems, the lesser trouble we have later. The math problem, and this is not, ML alone that eventually has a math problem. I mean, the quality of research work that happens in the world, everything has a tie back to math. One thing I have noticed, in my lifetime is the way kids are taught math. It is not surprising that many people either don't like math or are afraid of math. And I think that is a good indication that we should revisit how math is taught early in life in schools and high schools and colleges. Because once you get into your grad school, it's fine because you're not going to go for an applied math or advanced math class if you're not good at math. But the formative years, we should start teaching math in a better way, especially important in schools where, simple things like, the definition of pi or the Pythagorean theorem, they all have practical applications. And if we teach them those applications early enough and show them how math and nature works together and so on, kids will hopefully have lesser fear for math. And, once you get the primary concept straight, then, you can build on that. It is very difficult, as you rightly said, if you did not take math seriously in your early years. It's not like it is not doable, but it is a lot harder to learn later. And I think it is a problem that we should catch in school time itself and solve for it.
Yeah, because I think there's a few different pieces to this problem, right? There's an individual problem, which is you need to keep your career alive, and if you listen to this, you have some good tips for doing that. There's a corporate problem, which is you have to satisfy your clients' needs this quarter and the next quarter and beyond. And there's a bigger educational system problem, which is this is just one more example of how our educational system is really, really poorly aligned with the types of jobs and types of careers that are available now. And this isn't anything new, but I think it's gotten worse. I mean, when I look at you and I haven't talked that much about college and like what we did next, but when I graduated from my sort of hippie alternative liberal arts college, when I look back, I'm really grateful for all the stuff I learned around writing and critical thinking. And, you talk about ethics. We were all over that. But then I also spent a lot of time learning about, deconstructing the economic system, but not much time learning about how to function within it. I never took a class on resumes. I never took a class on creating a business plan. I never took a class on analyzing or building a spreadsheet. None of that stuff ever happened. None of the applied stuff. I did take some advanced math in high school that I think has helped me later on, and I was lucky for that. But there was a really big missing piece there. And I think if you look at most curriculums today, even the good ones, you're going to find some huge holes, and then you have to figure out how to compensate for that later in life.
Oh, absolutely true, right? I mean, because I can tell you the reverse side of that story, given I had a technical education, I went to an engineering school, and, eventually later learned, later went to a business school. I had the reverse problem, right? I was good at math, good at physics, mechanics and so on, but didn't get a chance till later in life to educate myself on the liberal arts side, right? I was very fond of history. My grandfather was a history professor, so he gave me a good start. But during my college years, I completely missed out on that, right? So my understanding of how societies evolve, ethics, and so on, it would have been a whole lot more useful if I got a strong foundation in college, which I did not, and had to pick it up later. Thankfully, I had good mentors in most of those disciplines that I thought I eventually could catch up. But I think that the education system, right, that one of the easier ways to solve this problem is to go to the early years, right, and make sure that the next generation has a more solid, more broad-based education system, than our generation had.
Yeah, and you look at things like wanting to make sure that no one's excluded from learning how to code, right? That you'd like to think that instead of, I think there's a cliche that, oh, the next generation is so digitally savvy. And that is true. I mean, they're growing up with smart devices in ways that you and I never could have dreamed of growing up with smart devices so young. But do they know how those applications are coded? Have they coded applications themselves? Have they looked under the hood of that? And do they feel competent and encouraged to do that? I mean, to me, that's a really big thing, because you have to learn how to be a maker if you want to succeed in this economy, not just a consumer. And I think that's the big misconception is, oh, I'm a savvy digital consumer. Well, I'm sorry, but knowing how to scroll through your Facebook stream faster than someone twice your age is not going to do it.
No. Somebody on Facebook, one of the guys I used to work at SAP with, recently made this comment that the fact that you can drive a car doesn't qualify you as a car manufacturer.
Yeah,
right? Two very different things, right? So so I think this whole digitally native thing, I think we have stretched the value prop quite far.
Yeah, well, and things come full circle too, because I think you told me recently that you were thinking of rolling up your sleeves more with doing some hands-on machine learning and algorithm building yourself. Is that still something you're thinking about doing?
Yeah, I still do that. I picked up that a few years ago, and usually spend my plane rides. I have long plane rides most weeks, so that's what I try to do to keep myself sharp. And usually most quarters I manage to get at least one new skill, or at least develop empathy for the folks who are actually doing the work. And it does help have more meaningful conversations. Also helps hire better quality talent, because once you know how difficult or easy something is, you can calibrate what are the type of skills you need to succeed in this market.
Are the experts on your teams impressed with your endeavors, or do they feel you have a long way to go?
No, my God. Thankfully, I don't have a direct team of engineers anymore in my current role, but at least I was realistic that I wouldn't question their expertise. I always granted them that they are bigger experts on the topic than I am. Just that I can make informed decisions on their behalf, and
right.
Yeah, that's pretty much the extent to which I would dwell on their work.
You can talk to them without needing an interpreter present, which is something.
Exactly. So, as long as I don't do code reviews for them, I think they generally let me be.
There's one final question I think is kind of important to touch on, which is when you talked originally about recruiting excellent data scientists from these elite institutions and stuff, the real flag that comes up for me there is just challenges with diversity, right? Because the more you hire from elite institutions, the more challenges you have in terms of hiring from a fairly privileged applicant pool. What are your thoughts in general on just this field and the impact of diversity?
It's a complex problem, John, right? One that many of us are actively trying to mitigate and make the world a little better, more inclusive, right? There are two aspects to this, right? One, we do need to hire more people from diverse backgrounds, right, based on gender, race, ethnicity, all those dimensions. And it is pretty tough because how much ever hard you try, there are always more dimensions than you can take care of. But you have to make a start, right? You cannot wait for the perfect solution where every dimension is taken care of. So start somewhere. Start with gender, perhaps, right, or ethnicity, right, or whatever. Start somewhere, right? It is still a lot better to act than think about a perfect solution that might be far into the future, right? So that is one principle that I very firmly believe in. But we do have that problem significantly in the world of AI. And it happens in various different forms. Like, for example, when we hire from college, I don't see this problem an awful lot, right? I mean, there are plenty of women who are doing grad school courses in these top institutions. So when we go to the tier one universities and hire, not as much of a problem. We do find plenty of talent. In fact, the superstars in my team, majority are women from the younger consultants, but they do have other challenges, like along the way, many of them either move on to other things, or stop working in this domain and so on. So by the time leadership positions are considered, I don't think across the industry we have done a fabulous job with diversity, right? And this will not solve just by taking care of the top of the funnel, right? I think top of the funnel we do have more diverse candidates coming in. It's a lot better than, for example, when I started my career. But middle of the funnel, as in when we get into the first leadership roles to the top leadership roles, it will continue to be a problem unless we fundamentally change how we operate in this industry. Thankfully, there are more women role models, more different ethnicity role models, and so on. Like clearly, I'm not a woman, so hard to say from firsthand experience. But I can tell you from the ethnicity side, right? When I first came to this country, it was not common to be an SAP consultant and also be an Indian and being treated fairly. That is not true anymore, right? Now there are plenty of Indians, so it is not you don't stand out in a crowd. You can you can be more. You are more accepted, right? In case there are many German friends that I have who helped me through the first part of my career, who now tease me, saying that now you in turn should turn around and help us navigate the situation, given now there are less Germans and more Indians. And that is true. I didn't notice that consciously, but when they tease me, I realize that that's a fair thing. So when that gives me some confidence that these problems will go away. But these problems wouldn't have gone away if my German and American friends actively helped me in the first part of my career. I would have given up. So I have some, while totally not firsthand, and when you don't have firsthand information, it is tough to draw parallels. But I would go on a limb and say that as long as we all have an approach to solving this problem and doing what is right for the next person too, as opposed to just for us, this problem will get solved, right? Again, I've now been in the workforce for 20 plus years, and I have seen, how the Indian community in computing, got better respect and more representation along the way. And with people like Satya Nadella and Sundar Pichai holding very high offices and being role models for many of us. So that gives me some confidence that with like people like Indra Nui and Ginny Rometty and so on holding high offices, there are more women who will aspire to do well, and there will be more men around them who will include them throughout the careers, as opposed to just focusing on any one part, like top of the funnel. I think these are all things that are solvable. It just needs the current incumbents, the current majority to think differently, act differently. I think we all think differently. It's a bigger question of whether we act differently.
Yeah, and I think the other big piece of the puzzle, which we won't talk about any further today, you alluded to it earlier, but it's then the challenge when we look at these tools, which have become very powerful in their own right. When you look at, for example, the power of a Facebook algorithm or the power of a Google algorithm, we've already seen how those things can get us into a lot of trouble in terms of reinforcing bias. But those tools can also be used to get rid of human bias in certain ways if they're designed well. So that's a whole longer discussion. But I think we then have to take that same mindset and make sure we're not duplicating it in the tool, but also taking advantage of the fact that sometimes machines can be more, quote unquote, impartial than we can in a way that does help us with these issues.
Correct. It can help or hurt, right? I mean, we just need to be very thoughtful, because the idea of automation is that it will increase efficiency. And if we are not very careful, right, and all the bad things that we have historically done will get amplified. And if we are thoughtful, all the good things that we want to do also will get amplified. It just needs us to be more thoughtful.
Yep. Design for inclusion, I guess, is sort of the thought there.
Exactly.
So, well, great. That was an excellent discussion, Vijay. Any final thoughts before we move on into the less fun part of our day?
No, I think we had a fabulous discussion. I mean, these are all topics very, very close to my heart, and I know it's very close to your heart as well, right? So it's always fun to catch up on this.
Yeah, and I'll try to put this out there in such a way that younger people thinking about this field will get a hold of this, because I think that's particularly something that I would want people to be thinking about, so they can avoid making some of the mistakes I know I did, and maybe you think you did as well. So, all right, well, I've got a little editing to do, and hopefully I can get rid of the construction noises, but I think for the most part that was pretty clean. So thanks for your time, Vijay, and look forward to continuing the discussion.
Yeah, thanks, John. Really loved it.
All right, later.